everyone, Miss Tui here. Today, you will solve equations using order of operations to decode missing color codes and complete a maze for your Ozobot to travel through. For today's lesson, you will need an Ozobot fully charged and calibrated, a pencil, color code markers, and your maze of operations worksheet. In today's lesson, you will solve each equation using order of operations. Then you'll use your answers to decode the missing color codes. You'll color the sequences of empty boxes to match your solutions and program your Ozobot to move through the maze. An operation in math is a rule you follow to solve a problem. The most common operations are what you know as addition, subtraction, multiplication, and division. For example, you know if you see a plus sign between two numbers, you are going to add one number to the other to see what they equal. If you see a division sign between two numbers, you know you are going to either separate the number into equal groups, find the number of groups, or the number in each group. But what about solving a problem with more than one operation? Do you just solve them in the order that you see them? Actually, no. You follow the order of operations, which is easy to do using PEMDAS, which stands for parentheses, exponents, multiplication, division, addition, and subtraction. For today's activity, you just need to remember that you always multiply or divide before you add or subtract. Today, you are going to help your bot get through a maze. A maze is a pathway that has an entrance and an exit or a goal. To find your way through this maze, you will need to solve equations using the order of operations to decode the missing color codes. Decoding in computer science is when you put a sequence of instructions back together. These set sequences will need to be colored in the correct order and put in the correct location on the maze so that your bot can travel to the end. Let's look at the maze of operations sheet. Do you see the entrance for your bot and the end location your bot must move to on the maze? Can you locate the decoding key? Now that you have all of your materials, you're ready to put your PEMDAS hat on. Look at the first equation near the start of the maze. 8 times 4 minus 5. The order of operations, PEMDAS, reminds you to multiply before you subtract. Following the order of operations, first you will multiply 8 times 4. What did you get? Did you get 32 as the product? Great. I'll write that here to help you. Next, you will subtract 5. Did you get a difference of 27? Super. So now write the answer, 27, after the equal sign for the first equation. A good way to double check your answer is to look at the decoding key. Do you see the number 27? Since you have solved the first equation, it is time to decode the missing color code. As you look at the decoding key, what color sequence does the number 27 give you? That's right, the color sequence is blue, green, blue. What do you predict this color code will program your bot to do? Great job finding the missing color code. You can now use your color code markers to color the first sequence of empty boxes along the pathway. What are some coloring tips to remember? Can you try this on your paper? I feel a loop coming on. You'll repeat the steps to complete the whole maze. The steps to complete your assignment are: first, solve the equation. Second, find your answer in the key. Third, decode the missing sequence. Fourth, color the empty box to match the sequence of missing code. Be sure to do that for all the problems on your worksheet. Once all of the equations are solved and the maze pathways are complete, put your bot on start. If your answers are correct and your color codes are in the correct order, your bot should travel from the entrance to the exit or the win code. I've used black markers so that I don't give away the answers, but you will have color codes on your paper. Remember to double check your solutions and your color codes. Before submitting your work, don't forget to check that your work has a solution for every equation, color codes for every color code slot, and your work shows that your Ozobot can travel from start to the finish. If you're looking for more to do, you can have your bot go over each color code while you pay careful attention to what the bot is doing. Then you can write the name of the color code underneath each color code. Then use your color code reference sheet to check if you were right.